This is Edexcel's GCSE Mathematics Practice Test Set 2, Paper 3F. Question 1. Write down the value of the 5 in 7.052. Well, the 7 is in the units column, the 0 is in the tens column, and the 5 is in the hundreds column. And the 2 would be in the thousands, but we're only after the 5, so that would be 5 hundredths. You could cancel that down, but it's only one mark, and it's after the place value, so you leave that as 5 over 100. Question 2. Simplify 4y minus y plus 2y. Well, 4y minus y would be 3y, and to add 2 y's to that, that will give us 5 y's. Number 3. Write 678,980 correct to the nearest 10,000. So this are the units: tens, hundreds, thousands, tens of thousands. So we want to round it to just here. So at the minute it's 678,000. So the 8 would mean that the 7 rounds up to an 8. So that would be 680,000. Question 4. Write down all the factors of 40. Factors are numbers that multiply together to give that target number. So we can start off with the easiest, 1 times 40. Then we will try 2, and that would be 2 times 20. Then we could try 3, but 3 doesn't go into 40. So we'll go to 4, and that would be 4 times 10. Then we could try 5, and that would be 5 times 8. Then we could try 6, doesn't go in. And we could try 7, doesn't go in. And then we've got back to here now where 8 is. So we've got all the factors there. So in order, that would be 1, 2, 4, 5, 8, 10, 20, and 40. Question 5. Lynn is planning a Christmas party for a badminton club. Here are her costs. So food is £176, drink is £103, and the hire of the room is £36 per hour. Lynn wants to hire the room for 4 hours. There will be 28 people at the party, each paying £15 each. Will Lynn get enough money to cover her costs? So first of all, the cost of the room is going to be this cost, and 4 lots of this. So if we times that by 4, 36 times 4 is 144. So if we add those together, we've got 144, 176, and 103. Again, this is a calculator paper, so you can use a calculator for that, but you get 423. So it's going to cost her £423. Here, there are 28 people, each paying £15 each. So 28 times 15 would be £420. So will she have enough money? Well, it's going to cost her 423, and she's actually going to only make 420. So no, she will be £3 short. Question 6. Sabrina throws a fair coin. On the probability scale, mark with a cross the probability that the coin will land on tails. Well, on a coin it's only heads or tails, so it's an evens chance, or 50% chance, or a half. So that would go in the middle. Question B. Suresh throws an ordinary 6-sided dice. On the probability scale, mark with a cross probability of it landing on a 7. Well, there are no 7s on a dice, so that's impossible. So that would have a probability of 0. There are 3 yellow and 1 blue sweet in a bag. Graham takes at random a sweet from the bag. On the probability scale, mark the probability of getting a blue. So there is 1 blue and 3 yellows, so that's 1 out of 4 sweets that are blue. So a quarter is just halfway between 0 and a half, so that would be there. Question 7. Mr. Wither sells umbrellas. The scatter graph shows information about the number of umbrellas he sold and the rainfall in centimetres each month last year. In January of last year, the rainfall was 6.1 centimetres, and during January he sold 32 umbrellas. Show this information on the scatter graph. Well, here is the rainfall in centimetres, so 6.1, there are 10 little divisions here, so 6.1 would be just there, and we need to go up to 32. So 30, 1, 2 is there again. Each square is worth 1 or 0.1. What type of correlation does this show? Well, it's going up in this direction, so it is a positive correlation. It says, in February of this year, Mr. Wither sold 40 umbrellas. Estimate the rainfall for February. Well, a lot of students would just go somewhere around about 40 and just go down. But we really need to use a line of best fit. So you need to take your ruler, and we need to get a line of best fit as close as we possibly can. going through the middle of all those crosses. So you need to get an equal number of crosses on either side, really set your ruler up so it's nice and in the middle, and then we can find our line of best fit going through the middle. So there, I've roughly got an equal amount on either side, and it's going right through the middle of all of those. So now I've got 40 umbrellas. I can go across to here and go down to here, and that would be 7.2 centimetres of rain. Now, obviously there's a little bit of leeway on that, so you can go either side depending on your line of best fit, but if you don't use a line of best fit, then you can quite easily find yourself going outside of that comfort zone. Question 8. Reflect triangle P in the y-axis. So the y-axis is this one here, so this is our mirror line, so we are 2 squares away, so we're going to go 2 squares away over here, and it will reflect to look in the opposite direction. Reflect triangle P in the y-axis, we've just done that, sorry. Draw an enlargement of shape Q, scale factor of 3. So a scale factor of 3 means we're going to multiply all of these lengths by 3. So along the bottom is 4, so our new shape will be 12 across. Now there's no centre of enlargement, so we can just draw this anywhere. So I'm just going to start here. I'm going to go 12 across, so that's 2, 4, 6, 8, 10, 12. Just fits on there. On the original shape it went 2 up, so I'm going to multiply that by 3, so 2, 4, 6. Along here is 3, so I'm going to multiply that by 3 as well, so 3, 6, 9. And then the diagonal is a bit more difficult to do, but you can just join it straight up because it should be correct now. But just to check, that goes 1 across and 2 up. So it should go 1 across and 2 up, 1 across and 2 up, 1 across and 2 up, and that's correct. So you can see it should just go through the corner of all those. Question 9. A pile of sand has a weight of 65 kilograms. Some of the sand is put into a small sack, the rest of the sand put into a large sack. The sand in the large sack weighs 15 kilograms and the sand in the small sack. What weight of the sand in the small sack? Well, this is where a lot of students do this by trial and improvement and just try and guess. But the best way to do it is to imagine that these are being split into 2 equal piles. So 65 divided by 2, if you use your calculator for that, or you can do that in your head, the answer is 32.5 kilograms. So if it was in 2 equal piles, it would be 32.5 kilograms in each. Now, it says the bigger one is 15 kilograms more than the smaller one. So it must be half of 15, which is 7.5. It must be 7.5 kilograms more than the middle. Because if the big bag is 7.5 kilograms more, the smaller bag will be 7.5 kilograms less. So we're after the smaller one. So the smaller one will be 32.5 minus 7.5, which would be 25 kilograms. Again, we could just check that. Add 15 to that, we get 40, and 25 add 40 equals the 65 that we're after. So the smaller bag would be 25, the bigger bag would be 40, and that will give us the 65 that we're after. Question 10. Laura is asked to solve the equation 6x plus 4 equals 10, and here is it working out. Laura's answer is wrong. What mistake did she make? Well, this means x is getting multiplied by 6, and then we're adding 3. So to undo that, we should take 3 off, and in this case, she's actually added 3, hasn't she? So the mistake that she's made is she has added 3 to both sides, not subtracted. And then the last step, she's done that correctly because she divided by 6, but it's the wrong number to divide by 6. Question 11. In August 2008, Eddie hired a car in Italy. The cost of hiring the car was £620. The exchange rate was £1 equals €1.25. Work out the cost of hiring the car in euros. Well, every £1 is worth €1.25. So if we do 620 multiplied by 1.25, €1.25, again you've got a calculator for this, it should give you €775. Eddie bought some perfume in Italy. The cost of the perfume in Italy was €50, and the cost of the perfume in London is £42. The exchange rate is still £1 equals €1.25. Work out the difference, so we're not after the actual cost, but the difference between the cost of the perfume in Italy and the cost in London. We want our answer in pounds. So what we need to do is we need to convert this €50 into pounds. Now every £1 is worth €1.25. So we need to see how many 125s go into 50. So we need to do 50 divided by 125, and that will give us 40. So that would mean that €50 is £40. The difference then, it was £42 in London, it was £40 in Italy, so the difference is £2. Question 12. An internet bookshop uses this advert. Each day, every third customer gets a mystery prize, and each day, every 20th customer gets free postage and packaging. On Tuesday, they had 150 customers. How many of the 150 customers had a mystery prize? Well, if there were 150 customers, and every 3 got a prize, if we divide that by 3, that will mean that 50 customers got a prize. How many of the 150 customers got free postage and packaging? Well, again, every 20th one. So if we divide by 20, that will give us 7.5 customers. Now, obviously, we can't have 0.5, so that would just be 7 customers. The 8th customer didn't quite get there, so the 160th customer would be the 8th person to win free postage and packaging. Part C, how many of the 150 customers got both a mystery prize and free postage and packaging? Well, for this, the 20th customer would have got free postage and packaging, but 3 doesn't go into that. The 40th customer would, but again, 3 doesn't go into that. The 60th customer would, and 3 does go into that. So that's where the 60th customer would have got both. The 80th customer got his free postage and packaging, but no mystery prize. The 100th, no mystery prize. The 120th, again, 3 goes into that. So the 120th customer would have got both. Then the 140, 3 doesn't go in, and 160, we don't get up to that far. So the 60th customer and the 120th customer win both. Now it asks for how many. So the answer is 2 customers. Question 13. Mrs. Phillips needs to decide when to have the school sports day. The table shows the number of students who will be at the sports day on each of 4 days. It also shows the number of teachers who can help on these 4 days. For every 12 students at the sports day, there must be at least 1 teacher. On which day do we have enough teachers? So if we do 179 divided by 15, again you can use your calculator, that gives us 11.9. So that means there's 11.9 students for every teacher. So that's not enough because we need 12 students for every teacher. Apologies, we've got 11.9 students per teacher, so that's enough. So we've got enough students for every teacher. On this one, we've got 162 students divided by the 13 teachers. That will give us 12.46. So there's more than 12 students here for every teacher, so that's not doable. On Thursday, 170 divided by 14 is 12.14. So again, we've got more than 12 students here for every teacher. And here, 143 divided by 12 is 11.9. So we've got less than 12 on these 2 days. So we need less than 12 to be able to run this sports day. So we'll be able to run it on a Tuesday or on a Friday. Question 14. 30% of a number is 120. Work out the number. Well, if 30% equals 120, if I divide that by 3, we'll get 10%. So 10%, 120 divided by 3 is 40. So 10% is 40. And then to get to the full number, we just need 100%. So 100%, multiply that by 10. The full number must have been 400. Question 15. Show that 7.5 take away 4 2/3 is 2 5/6. Well, these are mixed numbers, so we need to first of all convert these to improper fractions. So 7 times 2 is 14, add your 1 is 15, so that'd be the same as 15 halves. 4 times 3 is 12, add your 2 is 14, so that'd be the same as 14 thirds. So we've now got them as improper fractions. We now want a common denominator. Now, 2 and 3 both go into 6. So we're going to make these out of 6. If we times this by 3, that'll make it out of 6. So we need to times the top by 3, which will give us 45. We need to times this one by 2 to make it out of 6. So 14 times 2 is 28. 45 take away 28 is 17. So it's 17 over 6. And then to convert that back to a mixed number, there are 2 6s in 17, because 2 6s are 12, with 5 left over, so it'll be 2 and 5 6, just like it asks us to show. Question 16. The diagram shows a map of a field. The scale of the map is 1 centimetre represents 20 metres. A and B are 2 wind turbines in the field. A third wind turbine is to be put in the field. There must be at least 100 metres between the wind turbines. So 100 metres on our scale, if we divide that by 20, that would give us that 100 metres is 5 centimetres on this diagram. Show by shading where the third wind turbine can be put. So this time we need to get our ruler, and we need to get our compass, and we need to put our compass at 0 and open it out to 5 centimetres, as accurate as you possibly can. Then we put our compass at A, and we could draw our circle in for round A. Then we could put our compass at B, and we could draw our circle around B. So this here is the area where we can put our wind turbine. Now yours might look slightly different to that because of the scaling of the computer, but it's the same method. So you put your compass at 5 centimetres, you put it at A and draw your circle, put it at B and draw your circle, then anywhere outside of this is where you can put the wind turbine. Question, just get rid of that, and that. Question 17. The diagram shows the lines of a netball court. The court is made from 3 rectangles and 2 semicircles. All the corners are right angles. Mr. Handy is painting the lines for the netball court on the floor of a school sports hall. Work out the total length of the lines. So we're after the total length of all these lines of the netball court. Now, the netball court is made up of 2 lines that are 30.5 metres long. So 2 times 30.5 is 61 metres. We've also got 1, 2, 3, 4 lines that are all 15.25. So we want 4 lots of 15.25, and again that is 61 metres worth of line. We've then got these 2 semicircles. Now these 2 semicircles, if we put them together, so if I put this one and put it over here, it would make a full circle. And the diameter of that would be 4.9 plus 4.9, which is 9.8. Now the circumference of a circle is pi times the diameter. So we need to do pi times 9.8, and that will give us 30.7876. Write your full calculator displayed on there. But it asks us for just the nearest metre. So we can round that to be 31. So 61, add 61, add 31, again use your calculator, is 153. Question 18. On the grid, draw the graph of y equals 3x minus 2 for the values of x from -1 to 3. Now, a lot of students get confused with this. They think that from x from -1 to 3 means that you absolutely have to draw a table from -1 to 3 and work out all those values. However, a lot of students get mixed up with negative numbers. So I actually prefer to use y equals mx plus or minus c, where m is the gradient and c is the y-intercept. So in this case, the gradient is 3 and the y-intercept is -2. So it's going to cross the y-axis at -2, and the gradient means that for every 1 across, you're going to go 3 up. Now, the only problem with using this method on this one is that 1 across is actually 2 squares. So we'll go 1 across and 3 up. So I've actually gone up 3 there. 1 across is 3 up, 1 across is 3 up. And again in this direction, 1 across would be 3 down. Just got to be careful with the scale. Now we will join that up with a ruler. And you can see that my line goes past -1 and it goes past 3, so that satisfies this. Now if you did do it at the table, you would do 3 lots of -1 is -3, take 2 is -5. So -1, -5 was one of the points I'd have plotted. 3 times 0 is 0, take 2 is -2. So 0 minus 2 was one of the points I plotted. 3 times 1 is 3, take 2 is 1. And again, 1, 1, I plotted. 3 times 2 is 6, take 2 is 4. So 2, 4, I plotted that one. And 3 times 3 is 9, take 2 is 7. So 3, 7. So you could absolutely do it that way, but I just think it's a little bit easier to do it that way so we don't get confused with the negative numbers. Question 19. Abby is 5 years older than Kathy. Bavner is twice as old as Abby. The total of their ages is less than 30. What is Bavner's greatest possible age? Well, if I call Abby X years old, she's 5 years older than Kathy, so Kathy would be X minus 5, or 5 years younger than Abby. And it also says that Bavner is twice as old as Abby, so that would be 2X. Now it says the sum, or the total, of their ages is less than 30. So we're going to set up an inequality here. So Abby plus Kathy plus Bavner is less than 30. Now if we simplify that, we've got x, x and 2x gives us 4x, minus 5 is less than 30. And to solve that, we add 5 to both sides. So 4x is less than 35. And then divide by 4, you can use a calculator for this, but x has got to be less than 8.75. So the greatest it can be is 8. And so x is 8. And Bavner is twice as old as Abby. And Abby was the x, so we need to do 2 times 8, which is 16. So Bavner must be 16. Question 20. The table gives some information about the birds polar seas in a garden on one day. Complete an accurate pie chart. Well, the first thing we need to do is figure out how many birds were seen. So if we add up all these numbers, again, use your calculator, well, they add up to 72. There are 360 degrees in a pie chart, and if there are 72 birds, we do 360 divided by 72 equals 5. So each bird is worth 5 degrees of our pie chart. So 15 times 5 is 75 degrees. 10 times 5 is 50 degrees. 20 times 5 is 100 degrees. And 27 times 5 is 135 degrees. So these are the angles we need to measure. Make sure you put these numbers down, otherwise you won't get any working out marks. If you just start measuring and your accuracy is out, they will not give you any marks whatsoever. So, we need a protractor. We set our protractor up so that it's in line with the line that we've got, and we put it dead in the centre. Now we can see that the line that's been drawn is at exactly 75, so that's perfect for us as it is. We now need to move it. Now you can move the paper rather than going upside down, but if we put our protractor on the line that's just been drawn, and we now need to measure 50, because that one's already been done. So we now need to measure the 50. So start at 0, count round to 50, that would just be there. We then need to measure the 100 degrees from that line. So if I just move this out of the way for a second, we need to put that line in, and we can measure that, use a ruler, but it should go right through that point there. Now, set it back up in the middle again and rotate it around so that your 0 line is now on the line we just drawn, and we measure 100 degrees for the next one. So starting at 0, we count round to 100. It's going to be an obtuse angle, so it's this one here. So we're just going to mark here, and again we can just with a ruler make sure you go through that mark. Line it back up to the centre again. And we're going to rotate it round so that it's now on with that line. So again, starting at 0, we now want to measure 135. So all the way around to 135, we can see that that's right back where we started. So our lines are all accurate. So this here was already done for us at 135 degrees, and that was for the sparrow. Now the last mark for this question is actually for labelling it. So that 135 was the sparrow, this was the 100 degrees, which was for the starling, and that was the 50 degrees, which was for the thrush. They've given you a big clue that you've got to label it by labelling the first piece for you, alright? And that 75, we did check right at the start, was actually 75. Question 21. There are only red pens and blue pens in a box. There are 12 red pens in the box, and the probability of taking a blue pen is 2/3. So 2/3 is for the blue pens. If there's only red and blue in there, that means that the remaining third must be the red pens. And there are 12 red pens. We're told that that's 12. So if 1/3 is 12, then 2/3 must be double that, 24. and it asks for the total number of pens in the box. So if we add those two together, we get 36 pens. Question 22. Henry's thinking about having a water meter. There are two ways he can pay for water. He can either get a water meter with all these costs, or he can have no water meter and just pay £107 a year. Henry uses on average 180 litres each day. Henry wants to pay as little as possible for his water. Which one should he have? Well, this one's done for us, it's just £107. So we just need to work out all of these costs. So we want it per year. So he uses 180 litres per day. There are 365 days in a year. So 180 times 365 is 65,700 litres per year. Now it says here that it's charged in cubic metres, and 1 cubic metre is 1,000 litres, so we need to divide this by 1,000. And 65,700 divided by 1,000 is 65.7 cubic metres per year. Now it says it's 91.22 pence, so 91.22 times 65.7, and that would give us 5,993.154 pence. Now, all the other costs are in pounds, so if we divide that by 100 to get it into pounds, that's £59.93 pence, and obviously we can't have the rest of that there, and it's not going to round it up, so just 59.93. We need to add to the cost of that the standing charge, which is £28.20. So add £28.20 onto that, and we get a total cost of £88.13. So it is cheaper to get a water meter. Now, we actually have to write that, so you can't just leave it with the numbers, you've got to say what that means. So, he should get a water meter. Question 23. Here are the first 4 terms of an arithmetic sequence. A lot of people get confused by the word arithmetic. It just means that it's going up by the same amount each time. Find, in terms of n, an expression for the nth term of this arithmetic sequence. So we're just finding the nth term. So it's going up by 7 each time. So that means it must be linked to the 7 times tables. So the 7 times tables is written as 7n. 7 times whichever number you want in the times tables. Now the first number of the 7 times tables is 7. Our number is 3. So we need to take 4 off that. So the answer is 7n minus 4. Part B. Is 150 term in this sequence? Well, if it is, then when we put 150 into this equation, we will get a whole number answer for n, because that will tell us which term it actually is in the sequence. So we just need to solve this equation. So if we add 4 to both sides, we get 7n equals 154. And then divide by 7, we get n equals 22. So yes, it is the 22nd term in the sequence. Next question. Question 24. Each year, Wentford Hospital records how long patients are waited to be treated in an accident and emergency. In 2015, patients waited 11% less time than in 2014. In 2015, the average time patients waited was 68 minutes. Work out the average time in 2014. Well, we don't know the average time in 2014, but if we did, we would multiply that by 0.89. So 0.89 is 11% off 100%. So 100% take away 11 is 89%, and as a decimal that would be 0.89. And that would give us 68 minutes that we're after. So to work out what it was originally, you do 68 divided by 0.89, and that would give us 76.4, but to the nearest minute, that would just be 76 minutes. The hospital has a target to reduce the average time patients wait to be treated in the accident and emergency department to 60 minutes in 2016. Work out the percentage decrease from 68 to 60. Well, a percentage decrease is the difference. So the difference is 8 compared to the original, which was 68. And then we multiply that by 100. So 8 divided by 68 times 100 is an 11.76% decrease. So we'll round that to 11.8%. Question 25. Each length of the side of square B is twice the length of the side of square A. John says that this means that the area of square B is twice the area of square A. Is John correct? Justify your answer. So the key point here is that we have to justify your answer. You can't just put yes or no. Okay, so if a square measured 1 by 1, the area would be 1 centimetre squared. If I enlarge that by a scale factor of 2 and measure it 2 by 2, then the area would be 4 centimetres squared. So actually it's got 4 times bigger. So no, the area would be 2 squared, which is 4 times bigger. And that works for all squares, because if you double that side and double that side, it will make the answer 4 times bigger. So if it was 2 and 2, the area would be 4, and double that, 4 times 4 would be 16, and 4 to 16 is 4 times bigger. Question 26. Solve x squared plus 3x minus 10 equals 0. Well, to solve a quadratic, we need to factorise this into 2 sets of brackets. We'll have an x at the front of both, so because x times x is x squared. Then the number in the brackets need to multiply together to give minus 10 and add together to give 3. So our options are 10 and 1, which is going to give us miles away from 3, or 5 and 2. So we're going to have a 5 and a 2 in here. Now, because we want to be a minus 10, one of these is going to have to be negative and one's going to have to be positive. And because we want plus 3x's, we want the bigger number to be positive. So it's going to be plus 5 and minus 2. Now just to check that, x times x is x squared, minus 2x's, plus 5x's gives us plus 3x's, and then minus 10. So that's correct. And that's equal to 0. Now to solve this, this is just 2 numbers. So that's just a number, and that's just a number. So one of these numbers has to be 0. So x plus 5 has to be 0, in which case x would be minus 5. Or x minus 2 has to be 0, in which case x would be 2, because 2 take 2 is 0. So our solutions are minus 5 or 2. And that's the end of the paper.